Good morning, good afternoon, good evening, everyone. Thanks for joining us today. This is today's presentation about, let me click so you can see our slides, protecting applications with the OWASP API Security Top 10 and using static analysis. So today, I'm Arthur Hicken. I'm the evangelist at Parasoft. I get involved in all kinds of interesting cybersecurity things and functional safety things and compliance-related things. And I'll be talking a little bit later. And with me is Sandy Corelli. Sandy is a security analyst at Forrester Research and, like me, is a big security nerd. So she's got some really interesting stuff she's going to share with you today. So Sandy, take it away.
Excellent. Thank you, Arthur. And I appreciate being called a security nerd because I absolutely am. And I'm really excited to be speaking with all of you today. So we're going to talk a lot about API security. And leading into API security, let's talk about why APIs are interesting, why we're even going this route to begin with. What we've seen over the past several years are the possibilities that APIs offer to businesses to fully engage their customers in all sorts of new ways. You have here a picture of the Philips Hue developer website. And what Philips has done is they have offered a full API to their users so that you can program your lights to do all sorts of things, blink in the color of your favorite sports team, turn on at certain times of day. You have a lot more flexibility and engagement with the product. And so organizations are realizing that they can leverage APIs for their products, for their web applications with their partners to create all of these really unique customer experiences and create stickiness and customer satisfaction. It also allows them to increase their speed to market because they can really leverage the APIs to build new applications, build new ideas much more quickly. So there's a lot of great business application and possibilities with respect to APIs. And when we talk about APIs, I think it's important to differentiate that there isn't just one type of API. Very often we talk about APIs in general, but we kind of look at it in four ways. There are open web APIs. Those are what are exposed and available to the outside world, to external users. They're often what we might use to get user information, to get financial information, to get information, from a web application, to make calls back and forth. There are also B2B partner APIs that are often going to be leveraged by your partner organizations to share data back and forth. And there are internal APIs that are going to be used for your organization to increase the efficiency and the collaboration with your org. Then there are the product APIs, such as the Hue that we just talked about, that are really about controlling a product that a company makes. So when you think about APIs, you really have to think about the whole range of APIs that are available to the market. Now, we've talked about, why APIs are, to some extent, kind of neat. But the other part of this is that with interesting use cases for APIs, they're also becoming a really critical exposure point. And what we're seeing is that most organizations are exposing more and more of their applications to the internet via these APIs. And that becomes a challenge because now you have to question how those APIs are being secured and what data could potentially be exposed through those APIs. You can see from the data that we're showing here that over a third of respondents are exposing more than half of their applications to the internet or to third-party services through APIs. So imagine you have a huge number of applications that were perhaps beforehand just exposed through web interfaces. And now there are APIs that are available to a wider range of users, third parties, partners, everyone, and they can request data and have a lot more flexibility with your application. So there's an additional exposure surface. Why is that a problem? Well, because applications are still the most common way in. We found that 31% of firms suffered some sort of breach as a result of an external attack, and applications are the most common way that attacks are carried out. You can see that the number one way an attack was carried out was through web application, through SQL injection, through cross-site scripting, what I would call those sort of tried and true attacks that we've been dealing with for 20, 25 years now, Arthur, something like that?
Yeah, SQL injection, I have the Hall of Shame because this is one of those things that we've understood for 20 plus years and still happens on nearly a daily basis.
Yeah. And then we also have, software vulnerabilities, exploits in various libraries, whether they're open source or closed source or other libraries that are also being exploited and make it easy for attackers to get into applications and get into organizations. So if applications are the most common way in and APIs are providing additional exposure to applications, we can kind of see why there might be a problem. But Arthur, what is it about APIs that's adding to that risk? What else is making this horribly go wrong?
Yeah, so on one hand, the APIs are external, but what we're seeing, and as we look at the data in a few moments, we can back this up, that people built some functionality internally. You and I build something, we use it together, and then another group comes along and says, hey, I need access to that. So we expose the API to them. Then they say, hey, I've got this partner. And so they expose it through the internet. And the partner says, hey, I'm going to use this in my supply chain. And they expose it to a whole bunch of other people. And so a lot of times we get unintentional or even unrecognized exposure of APIs. And even more often, probably, these APIs simply weren't built with the idea that they were going to be exposed. And so they don't have proper authentication or controls or data monitoring or data limiting or all the other things that you see here.
Yeah, that's actually a great point. One of the things that I hear as a concern when I speak to a lot of customers and to vendors in the space is a developer suddenly or accidentally or intentionally exposing an API publicly that was perhaps never meant to be exposed. And what is your liability? What is your risk as a result of that? We've seen, and we talked about this earlier today, we've seen a ton of breaches that have been due to improperly secured APIs. We saw a proof of concept last year of a researcher that was able to leverage Starbucks APIs and get almost 100 million customer records, information about customer purchases that were through the Starbucks API. Earlier this year, end of last year, Parler had a huge breach as people were able to leverage their public APIs to get a huge amount of user information, messages, videos, posts that people didn't expect were going to be made public outside of the platform. We're seeing huge amounts of personal data collected. We're seeing potentially unintentional settings of APIs to be made public where suddenly your spending habits are exposed where you weren't expecting them to be. And a lot of the things that we see here are due to poor access control permissions. For example, not checking that a person has the rights to make the particular API call that they are, unauthenticated APIs, or even not checking on the server side who is making the call, whether they have the right to make that call, and what information they should be allowed to collect. I want to give you one particular example that I've been following quite a bit, and I think it's one of my favorite examples of an API problem. And this was India's COVID-19 contact tracing app that came out last year. Now, contact tracing apps were all the rage as COVID was taking hold in the world. And, we saw a lot of them out there, and we saw a couple that had privacy and security problems. In the case of India, there were two main issues. One, they were checking for validating the call at the client side. So they weren't doing any checking server side, and it was possible for a researcher to, yes, only a security nerd has a favorite security problem. You're right, Arthur.
Sorry.
No, it's absolutely, it's true. And this one was one of my favorites. So they were checking client side and they weren't checking server side. The researcher was able to modify the call on client side, as researchers have been doing for time immemorial, and a request for more data than they were expected to have access to was made. On the other hand, there was also insufficient authorization. So they weren't actually checking whether the individual or the device making the call had a right to be requesting the information they were requesting. The result of this was that a contact tracing app that was supposed to tell you who in your immediate vicinity was a potential COVID exposure was able to tell you who on the other side of the world was a potential COVID exposure. And you could suddenly, from Europe or the US, see contact tracing information down to a household in India. That's a huge privacy violation. It's a huge risk. those are the types of things that happen when you don't pay the same attention to API security that we've been paying to traditional web security over the years. Those are some of the challenges that we're seeing. Here's the good news in all of that. People are actually paying attention. I would say this was the most encouraging piece of data that I saw in Forrester's technographic survey this year. We asked security pros, what are your top tactical priorities over the next 12 months in security? And number one was improving AppSec capabilities. Number one. That makes me really, really, really happy. Also makes me happy, building security into development processes made the top 10. So what that says to me is that organizations are paying attention to this problem, that they recognize the challenges, both with traditional application security and with API security, to really take a closer look at this and make sure that they are not exposed in some of the ways that we've described. Arthur, what are your thoughts on this?
Yeah, so I look at this one, build security into development processes, and that is actually what I'm going to talk about in a moment, because we have to stop playing whack-a-mole. We can't just test our way to better security. On this is that glass half empty, glass half full thing here now. Like, it's good that 20% of the people want to build security into development processes, but you didn't just say that 79% of the people aren't going to build security into their development process. I hope not.
No, it's top priority. Doesn't mean others aren't. It's just
no. It's absolutely something we have to shift to. Not that we don't need red team activities. We totally need red team activities. We have to test that things work. But our security activities by the security team hopefully will become validation activities, proving that the system is secure rather than primarily poking holes in it that we're busy chasing.
That's a great way of putting it. Our goal as security professionals is to make security easy for developers, right? We want to build this into their tool chain so that they are able to, inline, in real time, build security into the application, make it easier, so that we're really only, as you say, finding the exceptions, finding those outliers and addressing those, but that everything else is really being addressed inline during the development process.
Yeah, exactly.
So as we look at API security, though, there are a range of problems. And when I talk to end user organizations and to vendors that are talking to their end users, they have shared with me, that there are a number of key challenges with API security. It's not just about the data validation. It's not just about the authentication, the authorization, although that is a huge part of it. The number one issue when I talk to a lot of folks seems to be, do we know what we even have in our environment? That discovery issue. Do we have a full catalog of those API endpoints? Because if we don't know what's there, what are the chances that we might be exposing something that doesn't have proper authentication, that is leaking a lot of data, and we just aren't aware of it? So that's often the number one issue that organizations come to before they even start to think about how are we locking stuff down. They're asking, what do we even have? Other issues are around managing all the user identities and managing access to all of those APIs, making sure that they are setting appropriate permissions across the organization. And then finally, look, there is a regulatory element to this. In a lot of countries in Europe and Australia, there are requirements to expose certain parts of your application and certain parts of your data through APIs. If you have to be using APIs, if you have to be making these available to partners and to the external world, you better be darn sure you're doing it in a secure way, because you don't have the option to say, we're not going to. The question becomes, how do we do it securely? How do we meet this regulatory requirement in a way that doesn't expose us to liability or breach? So those are some of the challenges that organizations are facing as they look at APIs. Here's another piece of good news in all of this. Even as people are struggling, we are seeing really aggressive adoption of API security. And Arthur, I would say that API security is probably, in the top 5, top 7 of customer inquiries that I get as an analyst at Forrester. There's a lot of conversation about it. There's a lot of interest, a lot of asking, what can we do? What do we look at? What is the range of tools that we need to be thinking about? And I'll get into that shortly. But one of the things that I do see as optimistic in this, we asked organizations, where are you implementing API security today, and where do you plan to implement it in the next 12 months? That dark green is in the next 12 months. And you can see that API security, like many other types of security, is shifting left. We're still seeing a lot of adoption in testing. We've seen a lot of adoption in production. But if you look at planned adoption, you have 42% of respondents that are planning to adopt API security in the development phase. You've got 23% that are planning to adopt it even in the design phase. So that's a sign that organizations are looking to address those API security issues early in the process. And again, not force us to find issues and find outliers late in the game. That's something I'm really happy about. And I think you're seeing similar, aren't you, Arthur?
Yeah, and in fact, it's interesting because when I think about API security in production, I feel like this is kind of well understood ops problem, and we have a pretty good solution. Yes, you need to deploy it and you need to configure it, right? But to get ahead of it and to get into a continuous cycle where we can do real DevSecOps, we've got to move left, and we've got to start doing things when we're coding, not just when we're testing. And as we're going to see when we talk about a few more breaches, having the wrong design, you can't fix it. You just can't fix bad, right?
Mm. It's funny you say that. I'm not quite as bullish of you on some of the operational issues. As I'll talk about shortly, it's still a bit of a patchwork, and there are a lot of different parts to secure. But one of the things that I do like to guide people on is the need to approach API security at multiple stages. You talked very clearly about, really needing to address this in development. And what we're seeing is we need to, address the governance issues, look at this in development, look at it all the way through into the operational deployment side. And then also look at API security, not just from the client side, but all the way through the stack. So how are you addressing it at the client side? What happens as it goes through the network, to the interface layer, to the implementation layer, all the way down to through the infrastructure? And what are their protections and the controls in place to really manage who is making the requests and what access to data they have? There's a high level of complexity with respect to API security, I'd say. It's not just a single solution. And that there is probably one of the biggest challenges. And I know you're going to talk about this a little bit later. The range of tooling and the need for the application security testing tools. Some of the challenges that we see are that there are different tools that address different parts of this. We're seeing API management help define API specification files, which are then becoming critical to help define rule sets in WAFs and in bot management. We're seeing API gateways manage some of the authentication and the authorization, the rate limiting. We're seeing WAFs help protect API calls by creating a positive security model and limiting the calls that can be made to what's defined in an API specification. You'll talk more about some of the testing tools that we're seeing out there. We're also starting to see a range of API security specific tooling that's really focused on API security testing or API security protections in production. So what I would say is that there are a lot of tools that are out there. Some of them are tools that you probably already have in your environment that you're using to protect your applications already that can be extended to APIs. And it's going to be important to talk to your vendor and talk to your team about how those can be extended to address API security. But beyond that, then you need to understand what gaps may still exist and what you may need to do to address those gaps. So it's not a unified solution yet. I wish it was, but we're getting closer. And we do have a lot of these different layers in place that address, and I'm going to go back for a second, the range of the usage requirements, the range of addressing this from development through operations, from client side all the way through the infrastructure. That's what we're looking at.
And I thought it was interesting, Sandy, you used this quilt metaphor about the patchwork. And if you get that mix wrong, it's ugly and it's hideous. But if you do it right, it can be beautiful, right? Like you get a beautiful security setup if you think about all the aspects and stitch it all together properly.
And use the right pieces. Yeah. And when you're making a patchwork quilt, right? You have to measure, you have to make sure the pieces fit together properly. You have to have a real understanding of how you're connecting all of the tooling. So you're right. There is a nice analogy fit in there. Thank you. So what is it that, I hope you will take away from this section? And, obviously Arthur has some more to share around this. What I'm not saying is to throw away your APIs. APIs are absolutely core to the business. APIs are what are going to allow many of your organizations to create new revenue streams, create new lines of business. As security pros, we're along for that ride. Our job is to enable that. On the other hand, we have to be aware that a lot of those application-based vulnerabilities that we've been protecting against for years also apply to APIs. So we better make sure that we are protecting the APIs from those same vulnerabilities. We also need to consider the fact that there are other vulnerabilities that can impact APIs that maybe we're not used to protecting against, and we need to make sure we're managing those as well. We are seeing really aggressive adoption of API security measures, but we also have to realize that it is about stitching a bunch of pieces together. So look at what you have, look at what gaps may exist in your environment, and then, fill them. Ultimately, API security is about creating a holistic approach. It needs to incorporate testing, it needs to incorporate production protections, it needs to handle everything, all the way from design through production, all the way from client side through to the infrastructure. And that's going to include that testing element, which, Arthur, I'm going to turn it over to you to talk about that now.
Yeah, and this is really interesting because when you think about APIs 10 or 15 years ago, they were that little sticker that said no user serviceable parts inside, and we had control of the user interface, therefore we could control access to the API, and suddenly we've lost it. And the consequences of losing it, I just lost my monitor for a second there, are all these breaches that we see. And we've talked about a few. This morning there was one, not Caterpillar.
John Deere, right?
John Deere, yeah. And we talked about it before the call, and it's just funny because on one hand you go, what are the odds that there's a big API breach on the day that we do a webinar? And the answer is maybe 50-50.
Yeah.
Because they happen nearly every day. One of the interesting things as we look at these few breaches that I'm going to talk about is we often just see that it's my user data. It's not necessarily that someone broke into a bank and ripped off their money, right? But that we're ripping off people's data to different degrees. And so people ask, well, why do I care? Right? Like, it's so what if someone knows every Facebook post I did? I posted them for public use anyway. And there's some very interesting scenarios that API abuse can be used for that perhaps people haven't thought about. A big one is when Apple Pay card first started, there was a pretty big fraud problem. It was close to a 10% fraud rate, which is a number that no banking system can sustain. And what happened is that we went from an era where security was a slow but trusted process. In other words, I'd call the bank, I'd ask for a new card. They would send a card to an address that was already on file. I'm not allowed to change the address on the call that asks for the card. So I had to wait for the card, but they knew it went to the right place, and then I had to authenticate it from an own phone number and things like that. So they kept fraud to a pretty low level. Suddenly, anybody could go and get an iPhone, activate it on an account that had a name that looked like it's me, and then take my credit card number that they pulled from a breach and take some metadata around me, mother's maiden name, what town were you born in, what high school did you graduate from, plug it in for the challenge questions, and instantaneously have card access. So we sped up the process, and at the same time, we reduced trust and authentication in the system. And the transactions can happen so fast that the fraud detection programs may give a couple of hours before they notice that something wonky is going on. So it became an actual real world problem. Again, I say, hey, so what if someone knows my credit card? I use it all the time anyway, right? Well, if they know that and your address and your phone number and your mother's maiden name, your money is getting stolen, right?
Yeah. That's the thing that drives me crazy about that. People might say, well, all this data is public, But when you are using APIs to get that massive a set of data, you're making things really easy for the fraudsters. And why in the world would you want to make things easy for the fraudsters?
Yeah, and that's really today, I would say as individuals, our biggest threat is some form of, identity theft that might lead to like full-scale identity theft, but can be quote unquote small. I want to say that facetiously now, but it might just be my credit card as opposed to my entire life, which is
Yeah.
bad enough, right? So there's all kinds of aspects of that. And the funny thing that came up too when you mentioned Starbucks breach, like suddenly my brain is going, am I worried more that they have like my mother's maiden name or that someone knows exactly what I drink at Starbucks? Just because I go to Starbucks and I order for my wife, I don't drink from there, and so I order these frou-frou drinks. And like now, I don't want people judging me. And the drinks I order there are so bad that when I say this is for my wife, the barista will say it's okay, we don't judge here. And I know by that statement that they are judging me. So I don't want my Starbucks data out there either. So there was a few other breaches that have happened recently. Again, just go research API security hack, API security breach, API breach, blah. Any particular breach these days has got a pretty high chance that it was an API. But we're seeing some interesting commonalities when I was putting this together. And what I saw was that a lot of breaches are really scraping.
Mm-hmm.
And by scraping, I mean that we've gone into an API that has a legitimate purpose. And we were able to do a couple of different things. One is maybe we could access that API without authenticating, either by design. Oh God, why do that? It should, by design, I should be forced to authenticate, but frequently not. And maybe I can, parameterize and permute and scale the searches. So I as an individual shouldn't be able to go in and, run a giant bot and look up thousands of people's phone numbers in an app to see if I can connect to them. And so the scale of the attack, the authentication of the attack, and what's being provided. And again, we're seeing things like in the Clubhouse one where you're supposed to be able to look up a user ID, like by a phone number, so I can find my friend and connect to them. But it's returning to all kinds of other information that wasn't necessary for the call. And so getting the right amount of data, no more and no less than is actually needed to answer the question that's expected, is a really critical thing. And who has access to your APIs and what are the rate limits to your APIs? And, Facebook and Clubhouse both claim that they weren't hacked. And in some sense, these were public APIs being used in the way that they were designed for. I can argue that the design was bad, but it is what they designed for. And so they're saying we weren't hacked in the sense that this wasn't a burglary. It was I left my house unlocked and there was a pile of money sitting by the door in a bowl. And it said, take one, leave one. And someone came up and emptied the bowl. Right. And that's exactly what's going on with these APIs. And so it tells us that the big problem is, again, that these APIs are obviously being exposed without thought to the security stance. And that's why I wanted to talk about what on earth can I do about it? Right. To me, that's the interesting question. So there are a couple of great places to start. And I presume if you already have perfect security, you're probably not sitting on this webinar. So if you're trying to get started, there's two really good jumping off points. One is the OWASP top 10, right? The Open Web Application Security Project. They have their top 10, which is based on at least a bit of research. I wouldn't call it super scientific or academic, but it's an attempt to say we've looked at the things that can go wrong in web applications, and we have put them in order of things that are most likely to occur and most likely to be painful when they do occur. And so this has been a great help to people over the last several years. There is a new project. It doesn't have perhaps the same level of authority that the top 10 project has, but it's specific to APIs now, because as you've seen, APIs don't remove old security issues, but they're adding a whole new set. And so there's a new OWASP API Security top 10 list, and you see that number one becomes broken object level authorization, and then we have broken authentication, we have excessive data exposure, we have lack of resources and rate limiting, we have broken function level authorization. So you see there in those first five were all represented in my previous list of breaches. So they are really, really common things. So if you don't know what to do, if you don't know the granular details of how to get approaching what you should do, the OWASP API Top 10 is a great place for you to really get started. There are some extra challenges, and I do want to go into some of those. So I wanted to start with just kind of a big picture thought about what kind of tests are easy and what are difficult. And I have application testing here. I have it in green. It doesn't mean that we do it perfectly, but it is a problem that we have some pretty good understanding on now. We kind of know what it takes. It's still an effort. You have to be, rigorous and mature to do it, but we know what needs to be done to do application testing. And on the scale here, we actually see that certain things are more difficult. So if I look at something like API testing, it requires a lot more knowledge of code. I can't, literally take someone straight out of college or an intern and turn them into an API tester tomorrow. They have to understand the business logic of the application. They have to understand how the APIs chain together. And we see this all the time as a company that sells API testing tools, that customers are looking toward an idealized testing environment that we call like the testing pyramid. And clients constantly have a shape that doesn't look like a pyramid. It may look like an inverted pyramid or an ice cream cone, and it may look like a martini glass, and it may look like an ice cream cone with a cherry on top, and all these different problems that occur because API testing isn't simply black box and it isn't simply white box. Now, on the security scale, we also have difficulty, and it's because security testers need specialized training and tools. They think differently. They don't think like builders. They think like breakers. How can I get in the system? How can I abuse the system? How can I abuse tiny weaknesses for lateral movement to move sideways? The sideways move is the security tester's best friend. It's the ace in their pocket. And APIs, because they can be changed together in unexpected ways that will still be, I don't want to say legitimate or valid, but will function, are the security tester's best friend as well. So it takes a lot of really special training. And the really scary thing here is that API security testing is the intersection of these problems. I take all of the API testing problems and all of the security testing problems, and I kind of have to multiply them when I do API security testing. So there's a lot of challenges here. I can't just redeploy the existing techniques that I have and expect them to work. So what are the basic techniques that we have today, right? We have SAST and we have DAST, right? Static application security testing and dynamic application security testing. These are the primary tools people will use for API security. I can do both these with the regular OWASP Top 10. I can use both of them against the OWASP API Top 10 as well. They have advantages and disadvantages. DAST is nice because it's very realistic. It's deployed against the real application. It's very attack-centric and user-centric. On the other hand, it doesn't really know what happened inside the application. It can be difficult to reproduce. It must occur relatively late cycle because the application has to be at least in a mostly functional state. SAST, on the other hand, can occur very early, but it's language sensitive. You have to actually understand the code. But when you have a problem, you know exactly where it is, although you may not understand where in the application you specifically have to trigger to make it occur. And so we argue about things like, can this really happen? How hard is it for it to happen? And things like that. So I guess my point here is that a proper security profile uses both of these tools in the right way. There's a great little quote by Gary McGraw that I like, particularly the second paragraph here. Good software security practice leverages good software engineering practice, right? If we go back to GDPR that was mentioned earlier, it requires private by design and secure by design, meaning I have to start at step one and I need to build secure software. So, we changed from maybe a blacklist approach to a whitelist approach that I presume that, in a zero trust environment, that everyone has to be authenticated, that data is presumed to need to be secured unless I have an exception that says it doesn't need to be secured or it doesn't need to be encrypted. And there are software practices like around threads, around buffer management, around data validation, that if I build the software in certain ways, I can be sure that it can't be penetrated. So rather than looking for vulnerabilities, I can look for either the existence of proper practice or the existence of known bad practices. And in areas like functional safety, like in medical devices, in automotive, in aircraft, this is the primary function of static analysis, not just to find, a quasi-dynamic issue in a data taint, but to look at the underlying code itself and say, this code is code that one day will be breached somewhere unless we change how it's written. So I wanted to take a look at a classic kind of a workflow. On the left side, we have developers, we have an architect or team lead. Somewhere we make a security configuration. An important issue to remember is that your tool needs to make sure that everybody's on the same configuration along with whatever your pipeline is, your CI/CD system, your regular build system. It's important because if you're in an audit environment, imagine that somebody changes the configuration and it makes it to the developer desktop, but not to the CI or vice versa. You're going to have a mismatch between what's being done and what's being reported. And boy, an auditor will be like, a dog in front of a squirrel on that. They will chase it forever and you'll be in trouble. Your CI/CD system should produce interesting reports that you can use both to manage the process and understand where you're at, as well as the necessary assets to hand off to an auditor so that you don't go through a cycle every release and say, oh, let's go chase down the data we need to prove compliance. Additionally, like our system can push the CI/CD results back into the desktop as if they were executed there, giving the developer an experience that is just like they ran it on their desktop. So there are some disadvantages from a developer perspective about using CI/CD or build level tools. And if you do it right, you can take those away, and I'll show what I mean about that. So the developer's life centers around some form of an IDE, right? Somewhere where I can write code and compile code and test code. These days it might be in a web browser, but it's certainly not in my email tool. It's not in my Facebook. It's not in whatever, right? It's not in a normal reporting tool. So developers need their data inside the IDE exactly where they're working. And you see down here, for example, in a normal spot where I would find compile problems, etc. And that way it's linked back. I can double click things. I can go to the right line of code. I can right click. I can get documentation. Maybe I can do quick fixes in certain cases. And, then I can commit the code back to the source control system as I'm done with it. So this is the most effective workflow. If my CI/CD produces an Excel spreadsheet, then I open it in a tool. I find an issue. I cut and paste it into here. I try to find the right file. I try to go to the right line of code. I've literally seen in the not distant past customers do these kinds of workflows. They're just very ineffective. Sandy, you wanted to add something there?
Around the IDE and the workflows. There was a point I actually wanted to make about, aligning with the development team. One of the things that we're seeing with APIs, but also with other types of development, is that there's a lot of change, a lot of new techniques and new approaches. And one of the requirements is that security get ahead of the ball a little bit, right? That they understand what's coming in terms of, okay, now we're adopting more APIs, now we're adopting low code, now we're adopting containers, and make sure that they have the skills and the tools to protect and support all of this. So it's one thing, to be able to say, okay, we're able to protect what we have today. It's another thing to say we're able to protect what's coming tomorrow.
Yeah, and the developers need the skills, the tools, and the information that fits their lifestyle. All right. I say
Exactly.
that like okay, so I wanted to just show you. I'm going to show the Parasoft tools for a minute and show you some interesting things that we've done. So let me share my screen instead, and let me carefully pick the right screen so that we don't get infinite recursion. All right, cool. So this is a Parasoft static analysis dashboard. This one is centered around OWASP, and I have, it's the usual dashboard. I can take things and I can, drag them around and move them, and I can add new widgets that do whatever I want. I can tweak the existing widgets and change the parameters being used for them and things like that. Here I've done something funny, which is this risk matrix widget is one that we did. So OWASP has this whole thing around compliance and risk that you see. Let's put it at the top just for grins. And they tell you things like, item number 3 on the OWASP top 10 is easy to exploit, but isn't very prevalent or doesn't have much of an impact. And so they have all these different colors. And what we've done here is taken that and replaced it with an actual risk matrix so that we get the intersection. Because I don't just want things that are easy to exploit. I want things that are easy to exploit and have a widespread impact, and it's severe. And so I can do these really cool kinds of things now where I can click on these and see the items that actually correspond. So this helps me get to the right answers much more quickly. And in fact, I can do that kind of filtering here itself. It was defaulting to only easy exploitability, but I can go back and say, hey, what are all the issues that I have, all the impacts? And you see I have here, I don't know, a couple hundred, close to 300 issues. Again, if I just go back to, I only want things that are easy to exploit, boom, I'm down to 100 issues. I want the ones that are also easy to detect, and boom, I get to a smaller number. And prevalent, I want common or even widespread, and boom, I get to a smaller number. So there's a lot of interesting things that you can do to get to what matters to you the most. I would say that we also typically start with a proper configuration. And sometimes people who haven't spent a lot of time with static analysis mistakenly go to whatever tool they have and turn on all the checkers. That way is madness, right? You've got to figure out what's working for you in your environment, with your type of application, with your type of code, with the kinds of threats that you're expecting, et cetera. So we have here a whole bunch of different security configurations, CWE, OWASP. This is an OWASP API top 10 static analysis configuration. You can see that the checkers have been named. So this top one, I can see that it's what we call ACPST, but it's actually for the OWASP top 10, number 10. Down here, I have one for number 2, and I can see the description around the rules, what's its security relevance, how can the rule be configured and customized so that I know exactly that it's working with my frameworks, some examples of bad code, so I have some context around what to do, an example of how to fix it, so we get some context there, and some references, where did it come from, etc. So there's some really, interesting, useful, helpful things that get me toward a fix. And I even have, if I come back to this one, there's this cute little button at the right that says download PDF. And when I click it, it produces a happy PDF report that tells me when was my last build, what are the results of it, am I compliant or not compliant? And I see here with each item in the OWASP top 10 how compliant I am. I'm going to make that more bigger. There we go. I like that better. And so I see exactly where I'm compliant, where I'm not compliant. And I can see, we call this a weakness detection plan, but this is, when an FDA auditor or a GDPR or a HIPAA or a PCI auditor comes along and says, how did you do that? This tells you on the right all the checkers that I'm using for a particular OWASP item. So it's easy to map my security requirements to the checkers I'm actually running. And because the checkers have been named according to the standard, when the developer is working on an individual violation, they know exactly which security requirement they're working on. So it's very, very helpful in that sense. And like I said, there's all these nifty little widgets. We have dashboards for all the different kinds of, whether it's regular OWASP for .NET or, for Java or CWE, et cetera. We have all these nifty widgets. We can see the top categories I'm violating. We can see the top violations that I'm violating. When we click on a particular violation, we can triage it over here. I can suppress it. I can change priority for it. I can, tell somebody I want them to fix it or suppress it or review it. I can look at the history of the code if it's been changed. I can look at how long has the violation been there. I can get the stack trace and jump to individual pieces of the stack trace to better understand the flow. And again, in that documentation, I see the parameters, I see the kinds of issues. And actually down near the bottom, I can see even links to online training. So we have here a video in Vimeo that you can watch that's a general training on injection attacks. I have a PDF that's a self-guided course with that. I've got links to HackEDU, so you can get in-depth training on this kind of attack. So lots of just really cool stuff to help you get to, resolution and remediation. So let me go back to my slides. Let me hit that other button. Let me turn that back off. Stop sharing. There we go. And let me go back to my slides. So one other final there, and we'll get to Q&A in just a moment here. I talked a lot about developer experience in IDE, and you definitely need to do that. But I believe in a trust but verify, or a belt and suspenders model. You heard it earlier, where I feel like the build, the CI/CD's job is to validate the correctness of the security efforts, not to find security vulnerabilities, at least not as a primary option. We should be saying we did the right thing, we checked in the good code. So trust but verify means that the developers get the tools on the desktop, they fix things, and in the pipeline, I'm going, yep, we meet these standards. We've run whatever DAST we could do, whatever SAST we could do, and it came out clean. And that's the great way to do it, with appropriate reports, et cetera, that we can use both to manage the process and to get the auditor off of our back. I don't want to go too deep in this, but I know that if you've played with static or heard people's, complaints about SAST, they can produce floods of results. And by that, I can mean thousands or literally tens of thousands of results. And that stems from people not having a proper flow for how they handle what comes out of SAST. I like to call what comes from a SAST tool soot, because it what comes straight out of the tool. And to get it down to from a pile of coal into a pile of a few diamonds that I really care about, I need to make sure I'm configured properly. I showed you that a minute ago with the way that you can tweak parameters for frameworks and select checkers that fit your needs. There is severity models. People have sort of innate severities, high, medium, low, critical, et cetera, for each kind of a checker. That helps trim you down somewhat. You can go after criticals and highs, for example. We have implemented the risk models. I showed you that in OWASP, where they have these exploitability, prevalence, impact, et cetera. And that helps you further trim it down. Instead of just a generic severity, I can now say, well, it's a critical severity, but it's also a widespread problem that's easy to exploit. So I can really trim down that pile of issues to a smaller number. We have some AI ML tools that help predict which items you're most likely to fix and which ones you're most likely to want to suppress, to further filter those out. We even have one that does hotspots that looks for intersections between various data taint issues and finds that maybe further back there's a core validation thing. And if you fix that one place in the code, you might fix 20 or 50 or even 100 different security issues by fixing that one line of code. And ultimately, you can then have some human review that gets you down to your, here's what my most important are for me in my world. But there are ways to manage this. And if it's a problem, you either have the wrong tool or the wrong process. But don't give up on SAST. So in summary, and then we'll get to your questions, and I need to go look at the QA box there, but API security brings new challenges, not just your usual AppSec or software sec challenges. There is some guidance out there. The OWASP API Security Top 10 is a good starting point. It's not a good ending point, but it's a great starting point. There are ways to control noise for SAST, and having the right reports for SAST make it more effective, and also lets it make it easy to audit. Again, I always take the view that for the auditor, I want as much paperwork as possible so that I can kind of overwhelm them and just go, look at all the stuff I did. So with that in mind, I've got a few questions coming in, and hit the question box if you've got something specific, and it can be from anywhere in the slide deck. One of the questions was, when I hear about API security, I often hear in terms of REST APIs. What about older API formats like SOAP?
Yeah, I can jump in a little bit on this, Arthur, and you probably have some thoughts as well. Because, I think the questioner is right. Very often, a lot of the briefings that I get around API security start with REST, but I am seeing a lot. Going back to some of the things I talked about earlier, any organization is going to have a range of legacy and modern applications, and you're going to see legacy API types like SOAP. So I am starting to see a lot of the API security messaging go beyond REST and realize that they're going to have to support XML or support SOAP, and make sure that they can tell a full story around API security, not just around modern applications. What are you hearing?
Yeah, and it's interesting because APIs have become the bridge between these legacy systems, SAP and things like that, and big iron, good old-fashioned big iron being used by a lot of people, like big mainframe computers, and the APIs become the bridge both for more flexible, more agile software development for their web app, but also the interface to the mobile device that wasn't built with the idea of these big legacy systems. So that becomes important. But on the truly modern side, we've got microservices and WebSockets and IoT devices speaking funny ways in funny protocols. And, with the proliferation of IoT, and APIs are the thing that makes IoT work. Otherwise, it's just a smart thing. If you just put logic in a thing, it's not IoT, it's a smart thing. The I part is the API, right? So, yeah, you need more than just that. There was another one. How do API specifications help in security?
Well, that's a good one. And I can sort of tell this story in terms of the good, the bad, and the kind of cool. So the good is that, and this is particularly with REST, there's a way to define an API to specify, what function calls can be made, what the expected parameters will be, how you expect the API to be used. And what I'm starting to see in a lot of production side API security tools, particularly WAFs, but not just WAFs, is that they can leverage that API specification, potentially upload it and use that to create rules around how they should accept API requests. So you're creating this positive security model based on the definition of the API, saying any API call that is outside of this specification should not be allowed. That's the good. The bad is, well, this requires the specification to be kept up to date. So you are reliant upon your dev team and everyone to constantly update and change the specification file as you are updating the API. That's in an ideal world that works, but that's one more thing you're adding to everyone's plate. So that can be a challenge. The cool is that we are also starting to see some of the API discovery tooling, not only identifying the APIs that are in your environment, but actually using that to create a spec file when none exists, so that even if you don't have an up-to-date version, you can create one, upload that, and basically have that specification and create the positive security model that way. That's the cool part, that even if you don't have it, there's some tooling today that allows you to create it on the fly based on the calls that are coming in. So
Yeah.
yeah.
And I think these specs are really, really important, partly because it allows you to build things right, build them in a known way, know what to expect, because API abuse can be based on, improperly formatted data, data too big, data too small, data of the wrong type, et cetera, et cetera, et cetera. And so the more I know about what I'm supposed to do, the more I can make sure I program for it and check for it, and the more I can leverage that at attack time to say, all right, we tested the happy path. What about the angry path, right? So
Yeah.
yeah, super useful. In fact, in the quality and safety space, we know that improper usage of APIs, which may be improper documentation of API, what I thought was proper use, is a very common source of a weakness in the code which can be exploited. I just did want to say real quickly, I hadn't shown, Parasoft, obviously we're sponsoring this today. We have a big testing suite that includes static analysis tools, unit testing tools, coverage and traceability tools for Java, C, C++, .test, etc. We also have these functional testing tools, UI and API testing tools. So we work with Selenium through a Selenic tool. We have SOA test, which doesn't just do SOAP and SOA, but does all kinds of cool microservices. We have Virtualize, which helps me isolate pieces of the system, load and performance testing. So if you've got questions about different things, what can you do to get into a better profile, or want to hear about any of the other steps, we do have some reporting and analytics, as I showed you during the webinar. There are a few things here before I take the last question. There's a white paper about the business value of secure software, and Sandy has written some interesting things around that as well, about like how business analysts get involved in security process, et cetera, because secure software isn't just a thing that the red team should care about, or that the dev team, but what is the cost to the business of screwing this up, right? And that's the really interesting question.
Yes.
There's a blog over here. So Sandy's email address down here at the bottom, my email address down here at the bottom. There was a Forrester wave that wasn't security oriented, but was API testing oriented. I alluded earlier to how many different challenges occur because of API testing itself. And so if you want to know more about those, or if you've been struggling with those, the Forrester continuous functional test automation wave tells you about that as well. So there was one other question I wanted to take, and it was, hey, I've got penetration testing tool. I'm using it. Can I just point it now at the API user stories? And will that just, take care of me? And it's, well, yes and no, right? Again, it's your happy paths, right? People often describe APIs as puzzle pieces, and you assemble them in the right way and you get this beautiful thing. I completely reject this metaphor, because most puzzles can only be put together in one way that works. I think of them like Lego. They can be assembled in multiple ways, some of which are ugly and hideous and dysfunctional, and some of which are maybe more brilliant and more useful than the original tool. And as I mentioned earlier, the lateral movement. So if I jump into the beginning of a happy user path and then I make a left turn, can I get somewhere intriguing that the system didn't anticipate? And you're pen testing without deep knowledge of what all the APIs are, the discovery that Sandy mentioned, and how they're used and how they can be chained, can be really, really painful unless you have the right set of tools, like the things that we provide in SOA test with our smart API test generator and things like that. So it's just know that it's tricky, but it's doable. With that, any last words, Sandy?
No, just wanted to really thank everyone for joining today, and thank you for having me. This was a really fun conversation, Arthur.
Yeah, it's a lot of fun, and I hope that we can do it more, Sandy. We've got like a million little rat holes that we could have chased down here and talked about for an hour or two. So yeah, if you've got questions, thoughts, suggestions you want to hear about from us, maybe we can do something specifically for you. So please let us know. And thank you, everybody, for your attendance today, and we hope you have a great day. And bring your hat.
Yes.
Bye-bye.